Hello everyone, this is Prasanna Kumar Kota, CSC E4 KMIT, part of the AI video games project team, mentored by Dr. Devika Rubi. We aim to make a project or a game that is accessible by everyone, even those who are incapable of giving inputs through physical means like keyboards or mouses. So far what we've done is a gesture recognition through MediaPipe. As you know, we are intending to make a game that does not require any keyboard or mouse input. We are taking input through voice and gesture. We have implemented the gesture part of it, and the first way we did it was through MediaPipe. Here's an example of how the workflow would go. Simple, there would be a camera input. As you can see, there's an example of me giving an input which would be passed into Unreal, and the console output would reflect that. Now, what is MediaPipe? It's a simple open source framework. It is provided by Google and it calculates the gestures based on landmarks. There's 21 landmarks, starting with your thumb, 1, 2, 3, 4, 1, 2, 3, 4. Sorry, this is 1, then 2, 3, 4, 5, 5, 6, 7, 8, 9, and on and on and on, with each finger having 4 points and 1 point at the base of your palm. Here's a code snippet. So the script to evaluate the gestures through MediaPipe is split into 3 so that we can explain it in a simple way. This snippet simply imports MediaPipe library and CV2 and it initializes landmarks. As you know, in MediaPipe we calculate gestures through landmarks. Now, how it works? Simply we have now in this code snippet we're capturing images through the webcam or any kind of mobile device that captures live video feed. Okay, so here we are using cv2.video capture in order to capture video and then evaluating those frames. Hand detection simply is automatically provided in MediaPipe, and in this particular case the Google framework can be imported as a module in Python script. Landmark tracking, we can do that simply by calculating the distance between different landmarks and then therefore mathematically evaluating what gesture we would be seeing when XYZ distance can be detected. Now in this code snippet we can see that each frame is being processed and we are giving an output. So here we're counting the number of fingers. If it's 2 fingers it's jump, if it's 3 it's move forward, if it's 4 it's turn left. We connect this MediaPipe script with Unreal with the help of a Flask endpoint. Flask is another framework that also can be imported as a module in Python script. And in Unreal Engine we have a simple get HTTP request mode which is provided in Unreal Engine's blueprints, wherein we can directly get the output from the Flask endpoint. This is an example of the output. As you can see, this is me showing 2 fingers. As you can see here, it's evaluated as jump, which is also reflected in the console log. This is another example with different output, that is move forward, and here you can see it's turn left. Now, second part of what we did is gesture recognition through a custom CNN. What we did was we built a custom CNN in order to replace the MediaPipe script so that we can make the game more specialized and therefore the gesture recognition more accurate. Now, this DL model first was created based on this data set, that is leap gesture recognition from Kaggle. This dataset contains 20,000 images of different hand gestures in each directory. So there's 20 in this. Each directory contains 10 classes, that is palm, L, fist moved, thumb, index, okay, palm moved, C and down. This is a workflow of the CNN. We downloaded the dataset and used the CNN to train 20,000 images in 20 epochs, give an image output, image prediction output, which is this. This is the architecture of the CNN. The input layer takes 224 by 224 grayscale images. The convolutional layers, there's 3 convolutional layers with ReLU activation and max pooling. And then there are fully connected layers with about 512 neurons and dropout for regularization. And output layer has 10 neurons with softmax activation for gesture classification. This is a code snippet reflecting this CNN architecture in our model. This is the training of the CNN. As you can see, it went through 20 epochs of training, and at the end we can see an accuracy of 0.9868 or 98.68%, which I believe is a relatively high percentage of accuracy. is an example of the CNN output. The validation loss is here, and this is for the testing. The previous one was for the training. At the end of training, we estimated an accuracy of 98%, but as we can see, testing has revealed that there is an accuracy of 99.84%, which is higher and much more significant. This is a snippet showcasing the output under the code block, and these are the predicted outputs. We intend to do more and make this more specialized. As of now, we are getting an output in the console, but we are more than confident that we will be able to have the output reflected in our game directly. Thank you.